All right, so just a review of what all these things do. Does anybody remember what A does out in front? It can reflect over the Y up and down if it's a negative. But what does a number out there do? Stretches or shrinks which way? Vertically, yes. So it changes Y values, okay, up and down. B is the icky one. B inside of there does the opposite of what it seems because it's inside the function, even though in this one it's not in the parentheses. It is a horizontal change, and if B was like 2, it would actually take the x's and divide them by 2. Okay? So it does the opposite. If it's a big number, it shrinks or compresses. If it's a small number, it stretches horizontally and changes x's. All right, H you should know. What does H do? Left or right, okay? And K does up or down. All right, so we're going to look at these. Did anybody find one they thought they figured out? What do you have, Jada? Number 8? What? Thanks. Mary, this is yours. Okay, so number 8. What two things would be going on here for 8? Did I mishear you? Is it not what you said was 8? Okay. Well, inside the reflection would be where, guys? Yes, so it's reflected this way. So the bump would be over here, okay? Everybody with me so far? And then a +2 on the back would do what? Up 2. So my idea would be it should be looking something like that, okay, for that particular one. And Jada said I? Is that what you said? I think I seems okay for number 8. Let's go with it. We're going to check our answers at the end because some of these can get confusing. Does everybody have the paper out you're looking at? I don't have very good slides for these. I can like show you but by the time I just see how it could have flipped, and this is the original one, so the slides just aren't very good. It's better if you're looking at your paper. Okay. Did anybody get number 1? That one was pretty basic. What did you have? Hello? H? What do you think, guys? What's going on with this one? The words should just be down to. Everybody okay that H just moved down to? Okay, and I think I pointed out that 6 was pretty easy one. What's happening on 6? And inside -2 is the opposite of what it seems, so it should be right 2. Did anybody find one that looked like that thing shifted right 2? It would, oh, here. This point, right, would be like 1, 2 over here. So it would be doing something like that, further over that way. Well, anybody get that one? A? Okay. Ooh, yeah. I was looking at D, but D must be scrunched up a little bit too, huh? Okay, right 2 was A. That was this one. All right, then, by the way, you do have to do some of this on the quiz. They're not probably as complicated as these, and you'll only have a couple choices, not this many to pick from, but there is some matching. Okay, let's try number 2. Number 2, what does a 2 inside do? Does it affect X or Y's if it's inside? Affects X's. And it is a horizontal, remember it's the opposite of what it seems, so it's what? Horizontal shrink by 2 or 1/2? So that means all the x's went half as far out. So this would be here, something like this. It's still the same height, but over here, instead of 1, 2, 3, 4.5, it might only be like 2.5 or something. It's kind of scrunched up like that. B? Does B seem okay for that one? All right. Anybody have another? Oh, what about 5? 5 doesn't look too bad. I think we may need process of elimination, so I'm trying to figure out ones that look okay. This is written really funky, but what this really means, dividing by 2, is just taking half on the outside, right? So that is a vertical shrink, like the y values are changing. So it's like somebody sat on it. So let me go back and erase this. So that would be, instead of going up here to what? 1, it's only going up to a half, instead of the peak being up here. Instead of going down to here, it's only going down half as far. But the y's still don't change, so it should be doing the, oh, wait. The y's are changing, not the x's, Hofbauer. I'll get it right. So it should still be crossing at the same places. It should just look like somebody sat on it. I'm not doing a very good job. How about C? That work? Which one was that? This number 5. Okay. Now, this one is actually not too bad. We should be able to do this. Anybody know the 2 things that are going on 3? We start inside here. What do we call that? Left 2. And then an outside negative is, I'm just going to write upside down. Is that okay? It's reflect over x. Okay, so it should be upside down and left 2. So if we moved it left 2 and then flipped it upside down, something like that, I don't know. G. We only have a couple choices for upside down, right? E or G, and E is not looking right. Okay. That was this one. All right, what does an X inside do? Yes, an X inside would take this and make it, oops, okay. An X inside would take this and make it flip this way, okay? I did a crummy job. But then it also has a 2 out front, which would make it actually go twice as high. Anybody have a pointy bump over here? F? Okay, so it was reflected over Y and then stretched. 2 times the Y values. All right. This is stretched twice as tall and then shifted down 2 times all the Y's, but then down 2. So if I did 2 times all the Y's, it would be going down here and up here like this, 2 times the Y's. But then, I doubt it, I can move it, but then we're supposed to shift it down to, I don't know, does that look like anything? B or D? So let me calculate here. This was at 1. Ooh. So sorry. We stretch it up to 2 for the 2 out front. Which one am I even talking about? 9. Okay, thank you. Whew. Stretched up to 2, but then we moved it down 2. So yeah, that should be going through the origin-ish, which you said was D. That looked good. Okay. This is taking way too long. What do we got left? This should be upside down and inside, a 1/2 inside should be stretched out. I'm not looking at the things here, but it should be stretched horizontally this way. So this should, even though it's a 1/2, it actually makes this go twice as far this way, and this one wouldn't cross till way out there. And then what else did it do? So it would be really stretched this way. Yeah, that's horrible. And then we're supposed to flip it upside down. So it would be over here, really flat though. E is the only other upside down one. Okay. Whew, how you feeling? Like that was a half hour of torture? Felt like it. Okay. Did we get them right? Can anybody check their paper? H, B, G, F, C, A, E, I, D? Okay. Because last year I recorded the lesson and had one wrong, and then I felt really bad, or had 2 switched or something. Okay, we're on 12A. Here we go. What is the equation of the transformed curve? So y equals x squared is this light gray one. Can anybody tell me what they think they did to get the dark gray one? Now, let me talk about this for a second. This is where we're putting things in, okay? There could also be a B inside here. I don't think we have any that do. But just so you know where things are going, that's the parent function with the transformations. So I'm thinking right 3, down 1. So who can tell me where those would go in? I don't think A changed. There's no stretch or flip, so we don't need an A, Hofbauer. But it went to the right 3. How do we put that in? -3. And down 1? -1. Good job. Everybody good? Wow. Anybody awake? Good, Antoine? I looked over and it kind of looked like you were napping or something. You look frozen. Okay. This is a square root. It would look like this. Just so you know where the things are going in. Okay. What do you think? What 2 things happened? From the gray over to here, isn't that only left 1? Left 1 and up 2. Maybe I misheard things. Okay, left 1 and up 2. So pretty easy. No A again. So we just have, what goes in here? +1. Good job. And on the back, +2. Okay. I wish they were all this easy because I think it gets harder eventually. Okay. This is an x to the 5th, which is complicated, but anyway, it's the same shape as an x cubed. It's just a little flatter in here. It would look like this. Okay. So what do we think happened to get it over there? I think 3 things happened. It went, oh, is it B to the 5th? Sorry. It's the same shape, but yeah. You're right. Thank you. Definitely went like left 3 and up 2. Yes. But then what else happened? It flipped. Can we tell whether it flipped over the X or the Y? Actually, this shape, it's got origin symmetry. So I don't think it matters if it flips over the X or the Y. Only would matter if we did the order funky. Anybody think they got it? What's left 3? X plus 3 to the 5th and an up 2. And you want to put the negative inside the parenthesis or outside the parenthesis? Let's try outside. Now, we got to think about this, because it would slide left 3, which would be over here. Then it would flip upside down, which would make it go this way, and then up to, I think we're okay. All right. I did do a little Desmos thing here just to show you. Come on, go. Always write on it and then it wants to delete that little dot. Okay, now here we go. Okay. So here's the parent function. Let me turn all these off. Here's the parent function. We chose this one. Does that look like what yours looks like on your paper? Okay. I just wanted to show you that you could have also reflected it inside and then shifted, said after that, then I'm going to shift to the, this would be a shift left 3 first and then up. Where's that one showing up? Okay. So we could have also put this. We could have put that it went, which would have looked more like this, which is the same one. All right, just because it doesn't matter on that one. All right, this is a little aside field trip here. Putting an absolute value around. I had a really cool worksheet that used to do these, but it just, Miss Scoopta said it's not a big deal for calc. If you put an absolute value around an entire function, f of x is really y, right? So it takes all the y values and makes them positive. So it would look like this. If you put in f of x on the inside, it takes all the x's and makes them positive. It's really funky because it takes all these and it makes them do exactly the same thing as the positive ones were doing. Pretty weird, huh? We used to make some really cool drawings with that idea. All right, I just wanted to show you this one. The parent function, guys, for an x cubed, if you cube 2, it would be up at 8. 2, 4, 6, 8. So this is the parent function. Okay. What is this doing? The plus 1. Slides it left 1, so you would be here, 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 here. Okay? And then if you threw these absolute values around at the end, because it's on the entire function, it would take this branch off down here and make all those values positive. I did a lousy job. But this is what it looks like on the calculator. Okay, this is left 1. And the red one is what happens when you put the absolute value around it. Okay. Do you not even have that on your notes? Okay. Little commercial break. There you go. We're skipping that one. We're going to 20. This is really an open-ended question. We have this weird power function over here. Y equals an x to the 6th. It would look like a x minus h to the 6th plus k. If we were going to do some shifting with it, the power function itself looks like this. It's okay. So how could we make it open down? Any ideas? Yep, put a negative out front here. I'm just put a negative here. We'll rewrite it in a second. We need to stretch it vertically. What else? Where does that go? Yep, it's still a. So we need to put a big number or a little number out there to make it stretch. As long as it's outside the parenthesis, it's greater than 1. So we would need like a -3 out there or something. It's why I said it's open-ended. You can pick anything. And And then the weirdness is they want it to be in the third quadrant. So we just flipped it over and made it narrower, what we just did by putting that -3 out there. What could we do to move this spot over into the third quadrant here somewhere? We need to move it left. So plus something, okay? I suppose we should maybe move it down too so that it's actually in the third quadrant. I don't think I bothered on my Desmos. Let me just show you what I did here. So here's the, okay. Here's the parent function. They said make it open down, so I did that. I used a 4, okay? And then I shifted it over. So we could have also put like a -1 on the back and moved it down a little bit. Then it would totally do it in the third quadrant. It's just an open-ended question to get us thinking about what those things do. Okay. I probably should have skipped some of these because we're going to run out of time. Okay. We are supposed to take this function and move it 4 to the right. Well, what is the parent function, guys? Anybody know the equation for the parent function? Yep, y equals absolute value of x. Or if you were worried about where you're putting things, it would look like this, okay? So where are we going to translate 4 to the right? Inside, outside. Inside, and 4 to the right is actually a -4. This would be a good one. I could have put that on the quiz. That was pretty easy. Okay. Reflect over the x-axis and translate up 5. We're going back to the parent function. At first, I thought they wanted us to keep moving on adding to it, and I got really confused. We're just going back, doing a part C off of A here, okay? If we reflect it upside down, where does that go? Negative outside, and then translate it 5 up, plus 5 on the back, okay? Does anybody know how to find this in the calculator? Okay, here's the parent function. It is the orange one. We did left 5, or left 4 was here, x plus 4. Is that what we wrote down? And then a negative x plus 5 is the red one. Did they say upside down and up 5? Okay. In the calculator, just so you know, I think I talked about this one other time, but it is under math. Do you see where it says absolute value anywhere? I think the answer is no. Does anybody remember what you have to do? It's under math. Come on. Math. What's happening? Do I not have my pointer? No, I don't. Okay. Math. Really? What is going on? Math. Second, anything. I tried this. Math. Okay, that worked. Like if you needed cube root or something, that's there. But otherwise, if you go to the right, this is absolute value, okay? And this one is greatest integer down here, the step function, okay? So I don't know if you want to write those down. This was math, arrow to the right, ABS will give you the absolute values, okay? And then we're going to do one with the greatest integer function in a second. Can I move on? I'm skipping 12 and I'm doing 13. The parent function is y equals, instead of an absolute value, it's kind of the double absolute value thing. I ain't putting one of these on a quiz, I'm telling you right now, but how do you move it up 1? Yep, put a +1 on the back. And how do you vertically stretch it? by a factor of 4 goes out in the front. I think I have slides down here. So it would be 4 out in front and a +1. So that's the red one on my graph here. If I can find the graph. Did I slide it behind there? So the red one, does that look like it would be stretched vertically? And do you see how the original one was at the blue line was like from 0 to 1 and now it's up 1? All right, and then this one says compress vertically by 1/3. So that would be a 1/3 out here. And oops, how do we do left 6? +6 inside. So 1/3 on the outside and a +6 on the inside. Everybody see what I got down there? Okay, let's write that down though. It's math. Arrow to the right. And then I think it's number 5, INT. Does anybody double check me on that? Yep, right here, 5, INT. Okay. Is where you find that greatest integer function. And that's all it puts on the screen is INT, by the way. All right, number 14. Anybody know who the parent is here? Who's his daddy, huh? Anybody? If you look back, I don't know, it was actually in our parent functions. It might have been. It's on page 8B. It is a cube root. Okay, reflect over the y-axis. What's that going to be? Ooh, y-axis. That's not upside down. That's across. So where's the negative go instead of out front? Inside. So we're going to have the cubed root of -x inside. And then translate it 4 units to the right. Yeah, I'm not sure that's going to work. I think I had to double check that one on my calculator. Because, maybe it did. Okay, reflect, and then, because you would do, the order of operations would say to multiply and then subtract. So it's the red one on the graph here. All right, what's the other one? Compress by a factor of 1/2. Compress horizontally. Horizontally goes inside, and compress actually means you have to do what? Inside is the opposite, so it's going to be a factor of 2. It's a reciprocal. And then translate down 5. That one you should know. -5 on the back. Is that how I typed it? Yeah, mine is wrong. Mine's vertically compressed. Okay, we're going to ignore this. I need to fix that later. We wrote it right. We're just going to move on. All right. I'm going to skip this slide for a minute. If we have time, we'll come back to it. These are tricky and will not be on a test or quiz. They're really good thinking activities, but I'm worried about time. All right. Determine for this pair of functions what happened to make the first one into the second. This is really something kind of tricky that I don't know that I would put on a quiz. The first one doesn't really bother me. What changed from here to here? What did that do? If it used to be up 7, where is it now? Down at -4. So what actual change was that? How much? 11 down. I think that's what they want us to write. Do not start from a parent function. What transformation occurred? Yes. So this was just shifted down 11 because it went from 7 all the way down to -4. Okay. Number 2, what changed? Inside here, there was nothing, and so this would do what to it? Right, 6. That was easy. But on the back, it used to be up at 6, and now it's only at 3, so it went down 3. I would not get too carried away with that kind. Like this one, this is pretty basic. It used to be up at 3, now it's down at 2. So what happened? To go from positive 3 down to negative 2, it shifted how much? Down 5. Okay, and this one, the negative stayed. Thankfully, it didn't do anything with that. This meant it was at right 3, and now where is it? Right 8, so it went further to the right by 5. Okay, and back here, it was up at 2, and now it's down at negative 6. So it actually went a total down of 8. I don't know that I put that on a quiz, but it's good thinking stuff. All right, we're going to write some equations. This is on the quiz. All right, how do you move this down to first? Y equals x squared. Okay, x squared minus 2. Now we're supposed to reflect it over the x-axis, which is upside down. In order to get it to do this after you moved it down to, you'd actually have to put the negative outside a parenthesis. I would not ask that one on the quiz. And then vertically shrink by a 1/6 would be a 1/6 multiplied on the whole thing. So you could just put it here and then put the negative. That one's kind of ugly. Ugh, not on a quiz. Yuck. Okay. Right 6, horizontal stretch of 2. Where's right 6 gonna go? Inside or outside, guys? Left, right is inside, and it's the opposite of what it seems, so it should be minus 6. Horizontal changes are also inside, so they're the opposite of what they seem. So instead of multiplying by a 2, we're going to multiply by a what? 1/2. I don't have room to put that. Now, to do it in the order they want, I would put the 1/2 like this. You actually could put the 1/2 on the outside and it wouldn't matter for this absolute value graph. All right, these are more complicated than I thought. Don't freak out. Okay, this is an x cubed vertical shrink of 1/2. Where's a vertical shrink go? Outside, and so do I need to like flip it over or anything? No. So I'd have a 1/2 on the outside, x cubed. And then if I said I'm going to shift it up 3, I would need a plus 3 on the back. We're not doing the other part. Just pretend that's gone, okay? Because after the fact, you'd have to go back and do something weird, and I'm not going to go there. Okay, horizontal shrink of 1/2. Where's horizontal shrink go? Inside. And do we put a 1/2 to make it shrink? No, we put a 2. Okay, up 3, where's that go? Up 3 is on the back. And now if we wanted to reflect that whole thing after we've shifted it up 3, anybody know what we do? We'd put a negative, but we'd actually have to put it in parentheses because otherwise you would do the reflecting before you shifted up 3 and it would be different. Okay, just skip this on the quiz business because they were harder than I thought. I'm kidding. I will put that idea on the quiz and not that hard. Not that hard at all. Okay, here we go. I think this is kind of the last thing, which is good because we're getting close, right? How much time do we have still? Okay, we're good. So this is the parent function you have at the bottom of the notes, right? Okay. So what is happening Can anybody tell me some words they think, if this was f of x, some words they think happen to make it look like this? Two things happen. That's the trickiness. Up? Does that seem okay? Definitely up a little bit because it's not going below here. It's up one. Maybe. And then Ben is saying flipped left to right. Okay, which is across the y-axis. So it doesn't matter what order you do those two things. Reflect over y and up one. Okay, how are we going to write that? Reflect over y, does that go out front or inside? Inside. So we'd have a negative x inside, and then an up one goes where? Outside on the back. So let's see if we did it right. I put this in Desmos, and I actually figured out the equation of the original function. Okay, that's the original parent function, okay? Is this what we said? Inside and a plus one on the back? Does that look like theirs? The blue one? Yay, us. Okay, I spent a lot of time making those so that we could confirm this and show you. Okay, parent function again. Oh no, we have three things. Anybody tell me one of the things they think happened? What? Reflected over y? I'm not sure it is over y. I feel like it's over x. Isn't it upside down, guys? Because this would be a reflection over x-axis, okay? And then I think there's still some stretching going on and shifting maybe, because it says three things. But if this was f of x, I think we reflected it over y. I'll write that over here. Reflect over x, sorry. Which would be a negative f of x. But you shouldn't write that down because I think there's also what out front? Some kind of a stretch. The y values changed. What was this up to? 2, 4, almost up to 6? Y-wise? Y-wise? Okay, the y height was up to 6. Then we flipped it, and does it go down to like a negative 12? Anybody counting? So maybe a negative 2 out front. So now we're taking this and making it go down twice as far. Notice the graph paper changed. And that would go up twice as far. Okay. But what else happened? Because that's not where it is anymore. The bump is not on the little tiny bump is not to the right, yes? Isn't it to the left? So how far did it move over? Instead of going through the origin, didn't it just go one to the left? Okay. Reflect, vertical stretch, 2, and what did we just say? Left 1? How do we do left 1? Yeah, plus 1 inside. Now, the order that we just wrote it down is not what we're going to do according to this, what we wrote for a function, but I think it'll work. Let's check it out. This would tell us to go left 1 first. Okay, so that would be that, left 1 first. Then, it doesn't matter the order here. Flip it upside down and stretch by 2. Yeah, I think we're good. Is that what we said? Negative 2 out front and a plus 1 inside? Okay. We're going to skip that one. This was just some extra practice that I threw up here. I don't think you have these. But can anybody tell, what is this 2 doing out front? That should be a vertical stretch. So it should, guys, I'm just trying to stress to you that a 2 out front does not change X's, it only changes Y's. Can you tell which one that would be? Which graph down here? If this is the parent, you don't have this, but which one is stretched vertically by 2? C, yes, because this Y value is now down to -4. So a 1/2 would take that and do what? Instead of -2, it would only go down to -1. This would be D. Inside, though, what changes? The X's, and it does 1/2 of all the X's. So that's this one, A. And dividing by 2 would stretch it horizontally, so that one's B. All right. You are to do 13B through 15A, all the circled problems, okay? There's not very many. Yeah, there's like 2 on each page. At the top of 13B, though, you should do all of those matching at the top of 13B. That's really good quiz practice. Ooh, there's a little more than 2 on worksheet 14B and 15A. If you have questions, please be ready to ask on Monday. Okay? Next week, we're going to do piecewise functions. We are not going to have a